Welcome back everyone for part 3 of our algebra refresher. Now let's have another example of one involving fractions or rational expressions. X plus 2 over 2 equals x plus 7 over 3. Once again, remember your order of operations. Now, once you get practiced at this, you won't need to write that down as a reminder, but if you feel that it helps, then go ahead and do so. And we're running in reverse. Be careful with ones like this. The additions are not actually available to work with yet, because when we have fractions or ratios, we really need to think of numerators and denominators as entire entities. So those brackets there around the numerators help me to realize that they are the highest priority part. We can't touch them until we deal with this divide by 2 and divide by 3. So let's see what would happen. Now, if I leave the x plus 2 and I leave the x plus 7 where it is, I can actually deal with the divide by 2 immediately. The opposite of divide by 2 is multiply by 2. So I transpose the 2 to the opposite side and make it multiply. I can do the divide by 3 in the same step. The opposite of divide by 3 is multiply. So the 3 will appear over here on the left. Now the brackets actually make a lot of sense, because the 3 here has to multiply both the x and the 2. The 3 has to multiply all of that. Likewise, the 2 has to multiply all of this. So let's expand those. 3x and 3 times 2 is 6. 2 times x is 2x, and 2 sevens are 14. Now I'm dealing with the additions instead of the multiplication. So 3 times is higher precedence than add. So I'll deal with the, remember this is a positive 2. If there's no sign there, it's automatically implied to be a positive number. So I'll leave the 3x where it is, I'll leave the equals where it is, I'll leave the positive number 14 where it is. And I will deal with 2 steps at the same time here. Opposite of adding this thing 2x is subtracting 2x. Opposite of adding 6 on the left is subtracting 6 over there on the right. 3x take away 2x is a single x, and 14 take 6 is 8. There's my solution. I'm going to double check by looking at the left hand side, which is x plus 2 over 2, where we believed x had the value 8. 8 plus 2 is 10. 10 divided by 2 is 5. Now the right hand side, because it's a bit more complicated, we'll have to look at it separately. That's 8 for x plus 7 divided by 3. 8 plus 7 is 15 divided by 3 is also 5. So check. The solution, x equals 8, makes the left and the right hand side both equal to 5. They are the same thing. They're equal. Now let's try a bit more of a challenging one, shall we? Let's go with something like this. Let's try x plus 5 over 2, subtract x take 7 over 6 equals 8. Now, again, I'm going to insert brackets around these numerators so I don't end up forgetting that they are strongly connected parts. And I've literally got a situation here that looks like subtraction of 2 fractions. Now, you will recall from primary school, if you had something like 1 over 2 minus 1 over 6, you could not deal with that until you had the same denominator. You would have been told to do something like, whoopsie, try that again. You would have been told to do something like 3 times 2 on that one and 3 times 1 on that one, giving me 3 over 6 minus 1 over 6, giving me a common denominator of 6, and then you would carry on. We're going to do the same process up here. We are going to make a common denominator. We are going to go 3 multiplied by and 3 multiplied by on this one. So I'm going to have 3 outside x plus 5 all over 6 minus x take 7 all over 6 equals 8. Now that I have a common denominator, I can write one vinculum line with the 6, and I'll write 3 outside x plus 5 minus brackets x take 7. These brackets are actually crucial now because that subtraction sign has to apply to both the x and the negative 7. Well, as we've seen before, in a situation like this, it is the divide by 6 that we have to deal with first. So 3 times x plus 5 minus x take 7 equals 6 times 8. I'll start to expand the left-hand side now. So remembering to multiply both parts, that's 3x plus 15. And again, this negative has to apply to both. So it's minus x plus 7. Be careful on that. And 6 eighths are 48. I have a 3x take away an x, that's 2x. I have plus 15 plus 7, that's plus 22 equals 48. This is going to fall out nicely now. 48 take 22, 2x equals 26, x equals 26 on 2, x equals 13. We solved it. Now, of course, we will need to go back and check the original equation. So let's give myself a bit more room. The left-hand side was 3 outside the brackets of 13 plus 5, close the brackets, all, oh, I didn't go back far enough. It wasn't that at all. It was no 3 there. There was divided by 2 originally, wasn't there? The original one there was x plus 5 divided by 2. Subtract x take 7 divided by 6. Take 7 divided by 6. Sorry, I've made a bit of a mess of this one, haven't I? But that's looking a bit more like it, where x had the value 13. That looks a bit neater. So let's do this. So 13 plus 5 is 18 divided by 2 minus 13 take 7 is 6 divided by 6. 18 divided by 2 is 9. 6 divided by 6 is 1. 9 take 1 is 8. And the original equation was equal to 8. So that does equal the right-hand side. Check. We did it. It worked. So that was definitely a much more complicated one, but following the order of operations and reversing that order of operations still did get us there. Don't forget, in one like this, your basic idea of adding fractions with common denominators still applies. That was the first step. Thanks for watching. See you next time.